Dan, thank you so much for joining us on the debrief today. I'm super, super, super excited to have you on and talk about this very unique perspective that you bring to sort of this framework of thinking about responding to incidents generally with clinical troubleshooting. But before we dive into all of the good stuff, I'd love it if you could speak a little bit about yourself, tell us about your background, all that good stuff.
Sure. Uh, it's a pleasure to be here, Luis. I've been listening to a lot of this podcast, and the other day I was just walking around and I had this little song in my head, and I was like, "Where'd that come from?" Oh, it's the theme song. It's the little lo-fi hip hop thing from the intro. So I'm like really into it.
It's funny that
So
you mentioned that because I was considering changing it, but I probably won't anymore.
I like it. It's a little jazzy thing. Anyway, yeah. So I'm Dan Slimmon. I'm an SRE. I've been an SRE slash sysadmin slash Linux admin type person for 16 years. Uh, I so I got a degree in math and physics. I got degrees in math and physics, and then well, we'll talk about that in maybe when we talk about how I got into incident response. But I live in New Haven, Connecticut. I got a blog. I worked at HashiCorp, Etsy, and a couple other smaller companies. I'm just like I probably led hundreds of incidents and investigated thousands of production issues. So uh, you know, it's just I got in there. I can do it now, and I want to teach people how to do it well.
Yeah, completely unrelated to the topic, but we were just in New Haven this weekend, and we went to Modern, a pizza. Uh, it was very good. It was very, very good. I will say something very controversial. It is certainly not the best pizza I've ever had. I went in there with very high expectations. It was good, but I was not blown away.
Yeah, it's good pizza. If I don't see any reason. I don't usually go there because I don't really want to wait 2 hours in line to go to get a pizza. And there's like 10 pizza places of equivalent quality in New Haven.
Yeah,
But
but
I'm glad you came. Next time
yeah,
you're
no,
here, hit me up. I'll take you to a better one.
yeah, for sure. Yeah, we did take out, so we went to that little side window, and we're in and out in less than 15
Smart,
minutes.
smart.
But anyway, if you're listening right now and you've been to New Haven and had Modern or any of those other big three,
Pepe's
just reach
Sally's.
out to let us know what you thought. Um, but you just touched on incident management. I'd love to know what your first introduction to incident management was.
Sure. So, uh, I when I was in college, I was doing like physics. I was managing this big open Mosix cluster, running physics simulations. Simulate a bunch of dipoles bouncing around, and then see how they congeal when you lower the temperature. It's pretty fun. Um, and but what the I was the computer like administrator for it, and it was a very low pressure level. It was academia, so like if the simulation cluster is down for a couple hours, like we can just use blackboards and there's time to get it back up. And then I got a job right out of college for a political campaign, like uh, contributions and outreach tool set for political campaigns. Um, and we had just gotten a client who was a fresh faced senator from Illinois who was like, we were like, oh, we can, this is great because he's going to be in the primary. And then of course, Hillary Clinton's going to beat him. There's no way he's going to, but like, we can like learn how to run a presidential campaign this way. And, it's a very different pressure level to go from, uh, the server's down for a couple hours, it's okay, to like the next president of the United States is losing $20,000 a minute because the website's down. Fix it, fix it, fix it, fix it, fix it. So I ended up in a lot of those calls, and ended up in charge of a team of 4 or 5 sysadmins from time to time. So we just needed to be like super on top of things and learn as we went how to do it, because none of us really had experience in this kind of high pressure environment.
Yeah, I always wonder how people adapt when they make such a pretty, I would say, dramatic shift from obviously, like you said, no one wants to deal with a down server, but down server versus sort of presidential election, like one skews very, very high stakes, the other not so much. I'm wondering, just like generally, how did you adapt to that change?
I was young and I worked too many hours. Uh, and I think I didn't adapt that. I mean, I was able to do the job effectively and troubleshoot the problems and keep the communication going, uh, just by virtue of that being nobody else was going to do it, so it had to be done. But I did like work myself pretty hard for the first few years of doing that. I was like eating all my meals at my desk and not sleeping very much. So that's the story of adapting to needing to respond to incidents. And then the story a few years later was I had to, learn to take a step back and not respond to every emergency that I saw, and not eat lunch at my desk. So I think that's the experience of a lot of people who first when they first carry a pager, they're like, oh no, this is all the pressure. So you learn that it's not the end of the world, and you can handle it.
Yeah. I think we could have a whole separate conversation around this and like the psychology of adaptation and like realizing that you don't have to be at the forefront of everything and knowing like when it's okay to, I guess, sort of take your foot off the gas, so to speak. But we'll leave that for another day.
Yeah,
So I read through your blog, and I think one of the things that stood out to me almost immediately is that you approach, you know, incident management, incident response in a very unique way. So one of the things that stood out to me in particular was this blog post that you wrote around, tying incident response to like firefighting, where the difference is when, fighting fires, you don't care about what caused the fire. You're just concerned about, putting the fire out. Whereas with incident response, your concern is like how this happened, but you also need to fix it. So I'm just like wondering, as a general point, how did you start to approach specifically your writing in this way and like thinking about things in this sort of, I guess, unique, unorthodox way?
sure. Yeah, I mean, so I'm certainly not the first to compare incident response in computers to things like firefighting, disaster response, air safety. Um, it comes a lot from the human factors literature, which I got into through uh, John Allspaw of Etsy, and I think Colette Alexander, who was a friend of the show, was has is very versed in this stuff. So I emulate her with it. Uh, and the literature identifies like common threads among intensive safety intensive professions like these. How do humans jointly diagnose a problem and respond to it, uh, and what are the ways in which that process can go wrong? So firefighting is one where like I think we learn a lot from it as software incident responders about how to organize and delegate, radio with dispatch, that kind of thing, how to communicate and use those collaboration skills. But uh, like you say, the when you show up at the fire, you're not asking questions like who who started this fire? Were they what went wrong? Were they smoking in bed? Were they, was it a malfunctioning toaster? You're like, okay, let's put the fire out. Whereas in in software incident response, and this is also true in medicine, which is where I get this clinical troubleshooting approach from. But you in order to do something about the problem, you have to have some idea why the problem is happening. You can't there's an infinite number of actions you could take to resolve a problem, any given problem with the system. And in order to know which of those infinite paths to take. You have to develop in your head and the heads of your collaborators the same mental model about what the problem is.
I'm curious if you could speak to sort of your response or well, yeah, I guess your response to responding to incidents sort of before and after you adopted this approach.
Yeah. So I spent a lot of time, and I think a lot of people spend a lot of time uh, trying to either you work on your own and you just sort of have an intuitive troubleshooting approach and you're done when you're done, uh, or you are working with a group and then you you find it's like there's a lot of going around and there's a lot of stepping on toes. There's a lot of going around in circles. I find because different people will have different concepts of what the problem is or could be, uh, and so you can always get the problem fixed if you get the right people in the room, but it can be very time consuming and frustrating, I find. And then some problems, if you don't have a structured approach, you just never get them fixed. You're like, well, that's just a weird behavior of the system. Sometimes it throws 50, 503 errors in a row, and it's just not a big enough problem for anybody because the thinking, so much thinking would be involved in getting it fixed and so much time would be involved in getting it fixed. You're just like, I don't know. So so my one of the main things that has changed since I've adopted clinical troubleshooting consistently is that I will run down issues that uh, before I had this approach would have been, I would have just seen as like untouchable or not worth looking into, because I now know that I can, like, if I have access to a group of people, I can get to the bottom of any any problem that's part of it. May take a while, but like we can all get there. So I don't ignore issues anymore, which if I get surprised by something, I can go dig into it. The other thing that is better is that just like uh, I think that we have fewer and less severe outages because when we have a commitment to actually diagnosing, like having a solid hypothesis at least, and diagnosing the problem. Because often, like, there'll be an outage and it'll get fixed, but you'll never really understand why it happened, and those things come back unless you actually get to the bottom of them, and that's what we do with clinical troubleshooting.
Yeah, that totally makes sense. One thing that I'd love to know is like you mentioned there are some very influential folks in the engineering community like John Allspaw who have sort of made this connection between, like we were talking about before, like firefighting and incident response. Once you started to adopt that sort of approach as alongside clinical troubleshooting and you started to talk to your peers about it, what was their response like?
Um, I have I'm a I'm a guy who has like a lot of random ideas, and and I get excited about them, and no, usually people don't get as excited about them as I am. I'm like, what? Why? They're fun. They're ideas. So that the usual response is that people would be like, okay, Dan, uh, Dan's got another crazy idea about something he read in the Human Factors, and some people so if you just start, one of the nice things about this approach, which we'll talk about how it works in a minute, but one of the nice things about it is it's intuitive enough that if you just start doing it, people can follow what you're doing and why. You just start writing the things down, and even if that's not the way they would solve the problem, uh, they can follow what you're doing, and then that makes you the driver of the diagnostic effort. So I just kind of started doing it in calls, and then people start you start to develop a group of a core group of people who see it enough times that they're like, oh, I'm going to start doing that, and then it starts to build momentum. There's always people who just don't want to do it in a structured way,
Sure.
uh, and and okay, but if I'm, I know that if I'm in charge of the incident or the investigation, I can use this process. People can follow what I'm doing, and I know that if I do that enough times and show how effective this methodology is at getting to the bottom of things, then I'll get more and more support for it, and that's been my experience.
Yeah, for sure. You're always going to have, those skeptics, but like once you see it work, like it works. So yeah, there are some people that are going to be a little hard to sell until they see sort of the virtues of it sort of playing out. But we've
Totally.
talked about, clinical troubleshooting very abstractly. I'd love it if you could explain exactly what you mean by that.
Okay, sure. So you have a it's basically stolen from clinical medicine, where so if you have a patient with some set of symptoms, you're working on a group of doctors, each of whom, or a group of medical professionals, each of whom may have a different area of expertise. You get together and you say, okay, what are the symptoms? Uh, Based on those symptoms, what are they're called differentials in medicine? Basically, what are our hypotheses about what could be causing those symptoms? And then you say, all right, we have some number of hypotheses. It's probably one of the things on these lists on this list. So how do I rule out what tests do I need to do? What's the minimum set of actions I need to do to determine which of these hypotheses could be ruled out? And you do that repeatedly until it's like House MD, and you do that repeatedly until you have a until you make some intervention that fixes the problem, and then you know that what you just did fixed the problem. So you have generally have uh, a total, like a definitive diagnosis after you do that.
Would you be able to talk through this process using a mock incident as an example?
Sure. So for example, when I was working on an app that had a PHP. It was a PHP app, and it had an admin endpoint for administrative users to list all of the email addresses on their mailing list, and uh, and that's wasn't the only API endpoint, but there was a problem where uh, every few minutes we'd get a bunch of responses from the load balancer that were 503 responses. So I forget the official name of it, but it's like we tried to proxy your request to an upstream server and it didn't respond. So we're giving you back an error response. So we would get a flood of like, I don't know, 40 or 50 of these 503s every few minutes. So I pulled a teammate into a meeting room, started an incident. It wasn't like a Sev 1 incident, but it's like a Sev 2 where, yeah, we're sending error responses to these customers. We don't know why. So I had just been doing started doing clinical troubleshooting a bunch, and so I said, okay, here's what we're going to do. Walked over to the whiteboard and I wrote symptoms, hypotheses, actions at the top of the board. Okay, symptom one. Every few minutes we get a bunch of 503 responses served by the load balancer. And I asked my coworker, well, do we have any? Here's my best hypothesis about this, and I wrote it down on the board. Okay, the load balancer's network interface is crapping out. It goes away and then it comes back, and meanwhile all the connections are dropped. And I said, okay, now do you have any hypotheses about what it could be? Think for a bit. Okay, well, maybe on the web server Apache is crashing, and then all the in-flight requests to Apache are getting dropped. And so, okay, that's good. We write it up. We go back and forth a few more times. Maybe it's a router that has a network card blip. Maybe it was the web app that Apache is running. Maybe the web app itself timed out doing something. Okay, so we have one symptom. We have four hypotheses, And then we say, all right, what do we do? What is our action going to be? Well, we have essentially two classes of hypothesis up here. Either it's a web server specific event or it's not specific to a particular web server at a particular time. Therefore, our first action should be to distinguish between those two classes of hypotheses by running some test. And this is where like clinical troubleshooting really shines, is that you once you have that information on the board, um, you can choose like a very specific, highly effective action to take instead of, well, look for more data, think about it, read some. Once you see what your hypotheses are, you can always say, well, how can we rule out half of these, which makes the incident always go forward. Uh, so so we go and we check, when we check. So the action we take is, we go check the logs and see, well, in a given spike of these 503 responses, do all the requests come or correspond to the same web server? Because if they all correspond to the same web server, then it's something happening on the web server, not something happening on the load balancer or over the general network. So that we said, okay, yeah, they do correspond to the same web server. So that lets us rule out two of our hypotheses. You go through this, so you go back. All right, what do we know now? Write those down under symptoms. What hypotheses does that allow us to have? What actions should we take? You go through this loop until you have the problem solved and you know exactly what your definitive uh, diagnosis is. It ended up being something that we never have been on the list in the first place, but because we followed this process, we got, it was something like the web app was getting the results of some query, and it was running out of memory as it was retrieving the results from the query, even though it was very complicated in PHP. But so I felt vindicated for using the process, because once I looked at the hugely crowded board of stuff, I was like, how could we ever have figured this out if we were going around in circles with a non-structured approach? But here it is.
Yeah. One thing that I'd love to sort of focus in on for a second is that initial step of like pulling people together, because I can imagine, depending on the severity of the incident, it might be a bit of a slippery slope, because you might end up pulling in so many people that the rest of the process falls apart, because you're accounting for everyone's perspective and the way that they're identifying things, so on and so forth. So like, in your mind, like, what's the best way to pull people together in a way that you know balances having enough people in that you can get through the rest of this process as seamlessly as possible without letting so many people in that the rest of the process falls apart?
So yeah, so I try to have I think of it as like almost a spanning tree of the skills that I need in my. So based on what I know about the problem, what's the like the basis, the minimal set of people who probably know enough to get us moving to the next step of this incident, and usually that's three or four in the companies that I've worked at. You can end up with a lot more people than that on the incident call, but the diagnostic effort, where we're trying to figure out what's wrong, is best when it's a small group like that. I will say that if you're writing down your symptoms, your hypotheses, your actions, and making that artifact shared among the group of people who are responding, it can save a lot of bandwidth on the call, because people don't have to constantly be asking, "Have we checked this? Have we checked that? What is the do we have we thought about this hypothesis?" Because it's all right there in the doc, and so you can support a larger group of incident responders if you need to, uh, because the state is centralized and you're collaboratively thinking instead of each person having their own view of what's going on.
Yeah. In the blog post that you wrote alongside, or to explain this concept, you mentioned at the beginning that you, in your experience, you've noticed that teams can struggle to make process during investigations. How does this clinical troubleshooting process circumvent that, in your opinion?
Uh, so there's so there's I guess there's two ways. So first of all, there's always a next step when you have a structured
Sure.
process like this, when you're using clinical troubleshooting. In if you're using an if you're not using a structured process, then it, you can get to a situation where somebody's got tunnel vision about a particular idea and they won't let it go, and they're digging and digging and digging on that, trying to prove it. You can get into a situation where we're like, it's sort of the opposite of that. John Oswald calls it thematic vagabonding. I don't know if that's his term or not, but it's like, well, maybe it's over here in this system. Let's look at that. I don't see anything. Maybe it's over here in that system. I don't know. Uh, Whereas if you have if you have this structured, shared view of the diagnostic effort, uh, you know that if you don't know what to do next, well, figure out how to rule out one of your hypotheses. If you don't have any hypotheses that or any that can be ruled out, come up with some. Stop what you're doing, brainstorm. It's got to be something. So think of what just go crazy, think about some hypotheses, and then you can rule them out. If you can't come up with any hypotheses, then you don't have enough facts. Maybe you need to do more research or about the system, look at more graphs, see if anything jumps out to you, find where the surprises are. But I think that um, characteristic of it, where there's if you look at the board, you can always see something that you should do next to move forward, prevents things from getting stuck in the mud. Also, uh, I will say that the second way that it can help people make progress during investigations is when you join when you join an incident call, you don't generally know what facts and assumptions have already been established. You have to listen to the conversation and sort of work your way in, figure out where everybody's heads. Sometimes people write everything down in the. I think Victor, who was on one of your recent episodes, was talked a little bit about how you know people you really need to write things down when you think of them, and as your thought thinking around the incident changes, and that's good. Put it in Slack. Where I like to put it is in this clinical troubleshooting document, because then people who join the call don't need to like sort of wait until they have enough of the picture to contribute. They can read this doc. It's usually not more than 200 words, and then they'll know not only what's been tried already and how we got here, but also like where are the heads of the people in this call at right now, uh, so they can contribute. They can contribute to the effort right away on equal footing, which also makes incidents move faster.
Yeah. I think one question that I have is that it feels like in order for this to work well, like you said, someone who's coming in maybe towards the end or middle of this incident, they're looking at this, at this doc, and it's ideally no more than 200 words. But I can imagine that for some people, it might be easy to just turn this into just like a brain dump of just a bunch of information, at which point it becomes hard for someone who's coming in towards the end to get up to speed.
Yeah,
How do you think that teams can best avoid that situation where this just becomes like basically a brainstorm doc and they're throwing anything and everything into it, which kind of defeats the purpose long
totally.
term?
The structure, and that can happen. That does
Yeah.
happen. So the structure helps, because there's only 3 sections, and each section has a numbered list in it, and so every top level item in one of those sections has to be a symptom or a hypothesis or an action. They can't,
Sure.
and so that helps. But there's some wiggle room on those terms unless your team develops some discipline around it. So uh, then this is that's something that happens as more and more people use and talk about the process. But for example, at HashiCorp, when I was doing this, I had to um, I had to generally, if I was leading the incident we were doing, and we were doing clinical troubleshooting, I would have to sort of soft enforce I have to enforce some rules about what could go on the thing. So my rules are things like uh, a symptom. If it's a symptom, it should be objective and quantitative, as quantitative as possible. This number, this throughput on this app dropped by 40% at this time UTC. Uh, that's a good symptom, and it shouldn't contain any supposition about why the thing you observed happens. The suppositions come later. A symptom should be an objective uh, thing that you observed the system doing. The hypotheses have to be testable. They have to be falsifiable. If you can't think of any, you if anybody looks at it and says, so if some, for example, if somebody came up with a hypothesis that I thought was not specific enough to be falsifiable, I would work through that with them on the call, and we'd say, okay, well, how would I disprove this if it's not right? Because if we can't think of a way to do that, then it can't go on this list. If we start adding things like that all the time, then it'll be a mess, as you said. And so similarly, actions need to be uh, either generally you want an action to either be a rule out. So by taking this action, we'll get to rule out some number of hypotheses, or it should be research so that we can generate more hypotheses. Uh, if it's not directly, like, whoever's leading the diagnostic effort has to use their judgment to decide like what belongs in the doc and what needs to be reworked. Another good example is like symptoms. If you're listing symptoms, and you have symptoms of the problem that you're investigating, it's possible for somebody to make some other observation and add it to the list. And the group should, when that happens, when there's a new symptom being proposed, the group should be very careful to say, okay, is this actually, like, do we know this is a symptom of the same problem that we're already investigating? Because otherwise you can end up conflating. You can having, if you have 5 symptoms on the list, there could be 2 symptoms of one thing and 3 symptoms of another thing, and that's going to make it very messy to try to rule out different possibilities that could be happening. So as you do clinical troubleshooting over and over, you start to develop the skill at catching when something needs to be tweaked, and having that conversation early.
Yeah, absolutely. Yeah, that makes a ton of sense. One thing that I would love to know is, can any team implement this, or is there a specific signal that you are mature enough to, start thinking about clinical troubleshooting?
I think this is very intuitive to people when they see it done. Like, everybody's heard of science, everybody's heard of doctors, and they know roughly this is what you do. So that one, like I said, one thing I really like about this process is that it's intuitive and simple enough that you can just start. If you want to do it, you can just start doing it, and people can follow it. And then if it catches on, it catches on. Your team does it more. That's great. I think you know any organization where there isn't psychological safety, where you don't you're not allowed to be wrong, or you get punished for being wrong or thinking through something in a I don't know, where there's not psychological safety. Not there's no process that's going to work well, and this is no exception. You try to use this in a place where people are afraid to speak up because they might get made fun of by a senior dev. Like, you're not going to end up with the hypotheses that you need because nobody's going to speak up and say something that might be wrong. All right, but apart from that, like, slap it on. I say slap it on pretty much any team.
Yeah. I think that's a really good call out. Like, if there is no psychological safety, none of this will
Yeah.
work because this assumes that you have that safe space to be wrong about your hypotheses, potentially be wrong about the actions that come off the back of them.
Yes.
So I think it's a really good call out, and it, again, stresses the importance of psychological safety for all organizations,
Fundamental.
regardless of whether or not it's to do clinical troubleshooting or something else. People just need a safe space to be able to make decisions and be
Yeah.
wrong about those
All this
decisions.
stuff, everything you talk about on the podcast will not work in a psychologically unsafe environment. That's table stakes.
Yeah, absolutely. One thing that I would love if you could respond to is someone pointing out that this process might feel a bit overly prescriptive. What would you say to that?
Um, I've had people say that, or I've had people suggest that, or I've assumed that they people were meant that when they said things. I mean, overly prescriptive. So I try to dig into what what is it about the over prescriptiveness that's going to make us less effective. Uh,
Sure.
so if their complaint is that, because usually it has something, if something's overly prescriptive, it's overly prescriptive for some underlying reason, and for sometimes people are balking at uh, spending time organizing the ideas when you could just be off going and solving the problem. um, and some people are balking at the idea that the central activity on the incident call is going to be diagnostic rather than uh, fixing the problem. To those people, I would bring them back to the firefighting, explaining the fire point, which is that, well, we generally can't fix the problem until we know what's up, and also we can find what are called diagnostic interventions, where we're going to take some action that, like, restart a web server or whatever, take some action that, if it works, will we'll fix the problem and we'll know more, and if it doesn't work to fix the problem, then we'll still know more. The fact that restarting the web server didn't fix the problem means that we can rule out some set of hypotheses that we had. uh, Generally, you don't get too many naysayers, though, once they've seen it work a few times. The worst case I've had to deal with is people who were just like, okay, well, this is Dan's thing. Dan's going to go off and do his thing, and he'll probably get the answer, but, like, I don't have to participate in this because I think it's silly. That's okay. I can handle those people. I can work with those people. We'll get along.
Before we wrap, I'd love to know if you've witnessed people who make specific mistakes when trying to adopt this clinical troubleshooting framework.
Yeah. I mean, you make it's a I certainly have made almost all the mistakes that you can make with it, because that's how I learned how to do it right. And when you first start doing it, you're gonna make mistakes. Common ones are, but, like, you still get to the answer. It'll just take longer. So common mistakes
Yeah.
that you can make are having trying to prove. So if you have a list of hypotheses, it's easy to see one and be like, that's my hunch, I think that's what it is, I'm going to try to prove that. And you have to be very careful to focus on ruling things out in general, not in. I mean, if you can obviously, if you can find if your theory is that there's some error, and you go and you could find that error, that it happened in the logs and it happened the exact number of times that you got bad responses, then, like, you've just ruled out the rest of the hypotheses, because we know that this is the only thing that caused that to happen. Okay, great. But if you're looking around each other and saying, huh, what should we do next? uh, you need to remember to rule things out rather than trying to prove them, because you can go around in circles trying to prove things for arbitrarily long that can't be proven or won't be proven. And the other common mistake that I see people make is too uncritically accepting uh, new items on the lists. So, um, like I was saying, if somebody mentions a symptom, and if anybody who's helping in the diagnostic effort thinks uh, that might not actually be, like, that may be a red herring, that may not actually be part of this problem, that person needs to speak up and say, well, hold on, like, maybe we should get some more information on whether these two things are, like, we should at least have one hypothesis that states that these are two separate problems, because otherwise we're gonna chase our tail. So the mistake that people that mistake is, uh, you know, too too lightly allowing things onto the list without having them pass at least some bar of falsifiability or quantitativeness, or those characteristics that are important.
Yeah, for sure. It sounds like, in essence, it's about like being your own rabbit hole police and making sure that you're not chasing threads like
Can I use
infinitely.
that?
And
Yeah.
yeah, yeah. But it wasn't. I mean, you can, but it wasn't. It's not my idea. I remember Lisa, one of our tech leads here at Incident IO, mentioned that phrase in a episode that we recorded a few weeks ago. At this point, within the context of like running meetings and keeping them focused. Um, like we've all been in meetings where someone will bring up this talking point that has nothing to do with like the objective of the meeting, and it's sometimes you lean too much into that, and then now the rest of the meeting is completely derailed because you put so much attention on like addressing that. So like, yeah, being a rabbit hole
Yeah.
police and making sure that you're staying focused and on task, and in this case trying to get closer to a resolution and like figuring out what's going on as opposed to chasing all of these threads is like really important.
Moving keeps everybody moving forward, and everybody can be each other's rabbit hole police. And I feel like that's why I love it, is that instead of having each person doing their own individual cognition, we're collaboratively thinking, collaboratively reasoning, and that allows us to be more than the sum of our parts.
Yeah, yeah, for sure. Well, Dan, it's been great having you on. I think this has been a fantastic conversation. Count me in as a fan of
Yeah, let me
clinical
know how it
troubleshooting. I
goes.
think yeah, I think it. Yeah, when I run my next incident, I'll be sure to let you know how it went. No, but again, I think it just makes sense, and the approach makes sense in order to like you know move people along and get them closer to a resolution as quickly as possible. And I think in a lot of ways also it facilitates teamwork, which at the end of the day is also very, very important and something that shouldn't get lost in all of these
If you're
conversations.
trying to have shorter incidents, then you want to optimize for teamwork, right? Whether the
Yeah,
time is being taken by the fixing of the issue, or the time is being taken by the diagnosing of the issue, you know, either way, you're going to do better if you are reasoning together.
yeah, yeah, for sure. Well, to close out, I mentioned at the beginning that you have a blog. I highly recommend anyone listening to check that out. But do you have anything else that you'd like to plug that you might be working on right now? Any talks that you're doing, so on and so forth?
Yeah, check out the blog.danslimmon.com. Then we have Monitorama. You may still be able to get late bird tickets to Monitorama in Portland, but if you can't, uh, be on the lookout for the VOD. Anyway, I'm giving a talk there about theory and observability and the relationship between them. Sort of ties into with this stuff. And the last thing is, I have a 4-day incident response course on my website, d2e.engineering. So pop on over there, check out the course, see if that sounds up your alley.